These are the frequently asked questions for Algebra 2, and this will be for the first day of Section 11.4. Starting with number 8, it says use the table to find each probability. And so for number 8, it says you want the probability that they have a diploma. So what that tells me is, what I want is the number of people that have a diploma over the total number in the chart. And that's because this just says has a diploma. That's the only requirement that they have here. So what I need to do is I need to add up the people that have the high school diplomas, and that would be 54 plus 27. And I need to divide that by the total, which would be 54 plus 27 plus 5 plus 4. And that'll give me the total for the entire chart. So 54 plus 27 gives me 81. And then it just so happens that all we're really doing is taking our 81 and adding 9 more, which is 90. And then 9 divides into both of those very nicely. And we get 9/10. In number 9, it says the probability that they have a diploma and experience. And again, as I look at the problem, I realize that's out of everybody in this chart. So I'm still going to be using my 90 down on the bottom, but this time what I want to focus on is who are the people that have a diploma and have experience. And those are going to be people that are in both of those yes categories, so that's going to be 54. And then you go ahead and reduce that by 9 for each one of those, and we would get 6/10. Now number 10 is different because we see our little slash mark there for given. That means I'm not going to use the whole chart. I'm only going to use a certain part of that chart. Number 10 says the probability that they have experience given that they have a diploma. So what I have to do is I have to go find the part of the chart that just works with people that have a high school diploma. And that is going to be my total. That's what that given is doing. It's changing the group that we are looking at. And then what I need, as you read it again, is the people that have experience, but only from that row. So the people that have experience in that row are 54 people. So this is going to give us 54 over 81, and then 27 divides into both of those and reduces this down to 2/3. Number 11 is also a problem that involves a given. So in number 11, it says we want the probability that they don't have a diploma, has no diploma, given that they have experience. So I'm going to go to the column of the people that have experience, and that's where I get my total. So that is 54 plus 5, because that's my given, and that's going to be 59. And then, as I just look at that column, I want the people that do not have a diploma. So I cross-reference that and see that it's these 5 people that do not have a diploma. And so my fraction for that one ends up being 5 out of 59. On the next page here, I have another chart. We're still going to use this chart. Again, we're watching for that given business to know that we don't have to use the whole thing. But in 12, it says the recipient is male. And that means out of everybody in the chart, we want to focus on the males. And there are 245 plus 598 males out of 245 plus 598 plus 433 plus 858 for the total for everybody in the chart. So for number 12, that's going to be 843 over 2,134. Kind of a nasty fraction there, so you probably would put that as a decimal, and that is approximately 0.395. Then for number 13, the degree is a bachelor's. Again, we're using the entire chart. So that's good news. I get to use the total that I already figured out for the last problem. But now what I want to do is I want to add together the people that have received a bachelor's degree. So we have some males and some females. 598 plus 858 that have managed to get a bachelor's degree. So in number 13, when you add those two together, you get 1,456 over our total of 2134, and that comes out to approximately 0.682. Now on 14, we have to change up, because in number 14, we see that we have a given, and this time instead of using the slash, they actually wrote the word given down there. Don't let that fool you. We have to do the same thing. We have to say just out of this group. So the recipient is female, given that the degree is an associate's. Well, these people in this row are people who have earned an associate's degree. So that will be 245 plus 433 for my given. And then I want the people that are female that have that associate's degree, and that's this 433 right here. So I will need 433 divided by 678. Again, kind of a nasty fraction, so maybe better to put that as a decimal, which is 0.639. Then for number 15, try and fit that up here on the same page. The degree is not an associate's degree given, and there it is again, given that the recipient is male. So what I have to do is figure out how many males are in this chart. So we go back and look at the chart and we see that that is this column right here. So that's going to be 245 plus 598. Now just out of that group, we want to talk about the degree that's not an associate's degree. Well, in this table, if it's not an associate's degree, it's a bachelor's. So here's the bachelor's degree right there. So this will be 598 divided by 843, and that will be approximately 0.709 when you calculate that. So like the chart problems, and it's very easy to see what's going on as far as where your given information is and what you need to do with that. It gets a little more difficult when it's not in a chart form, and that's when we have to think of this as the formula that we talked about in class. So I don't have a chart for exercises 16 and 17. What I'm supposed to use is the survey information. And 16 says, find the probability that a respondent has a pet, given that the respondent has had a pet. So the first thing I'm going to do is I'm going to write this down using the notation that we do for probability. We want the probability that the person has a pet, given that they have had a pet. And then we need to think about what that means. And what that means to us is, when we are finding the probability of B given A, what we are supposed to do is find the probability of A and B divided by the probability of A. So we take a look at this situation, and like I said, we've got everything labeled as B and A, and what we have to do is find the probability that a person has had a pet now, and has had a pet in the past. So I looked through all the survey results and I realized, well, that's right here. They have a pet now, and they have had a pet. They're doing both of those things right now, and that is our and situation. So that's going to be 0.39. And then the bottom of this fraction would be the probability that at some point they have had a pet. That's right here. That's 86% from the survey results. So this is the fraction that we need to use. We take the and we divide it by the probability of A. And that comes out to, well, I better punch that one in. I didn't get it in yet. 0.39 divided by 0.86 is approximately 0.45. So about 45% for that one. Then number 17. Number 17 says, find the probability that a respondent has never had a pet, given that the respondent does not have a pet now. So again, really important sometimes to just write all of this down and then use the formula as you go. So this one is going to be the probability that they never had a pet, given that they don't have a pet now. So no pet now. All right, so here's our B and here's our A. And our job, find the probability of A and B and divide that by the probability of A. So let's go find this information. The probability that they have never had a pet and they do not have a pet now. So I go up here and I realize that's right here. Don't have a pet now and never had a pet. That's the 14%, so 0.14. And we're going to need to divide that by the probability that they don't have a pet now. And I look up in the survey results and see that that is 61%, so 0.61. And again, you go ahead and punch that into your calculator, and I should definitely put approximately here, 0.23. The next one that I thought maybe, just maybe, you might need a little help with is back here in the 30s. There we go, number 37. This says, what's the sample space for spinning the spinner twice? That means, what are the things that could happen when you spin the spinner twice? Well, you could get a 1 and a 1. That's definitely something that could happen. You could get a 1 and a 2. And you could get a 1 and a 3. Now, your first number that you spin could be a 2. That could come with a 1 after it. It could come with a 2 after it, or it could come with a 3 after it. And you certainly could get the 3 with either of those choices as well. So this is called a sample space. Those are all the things that could happen. And it asks, are all those outcomes equally likely? Well, we don't see anything here that's occurred more than once, so the answer to that would be yes. You know, we have a 1/9 chance of getting any of those to happen. And that is it for the first day of 11-4.